In this video, we're going to use Newton's method to approximate the value of a radical expression. It says using Newton's method with x sub 0 equal 3 to approximate the fourth root of 12, find x sub 3, round your answer to the nearest thousandth. So Newton's method is x sub n plus 1 is equal to x sub n minus f of x sub n over f prime of x sub n. Now what we want to do is we want to change this into an equation. So we're going to say that x is equal to the fourth root of 12. We take the each side to the fourth power, so we have x to the fourth is equal to 12. And then we're going to subtract 12 over, and we're going to say that f of x is equal to x to the fourth minus 12. Now we did all that so we could find the derivative for the equation. So we're going to say f prime of x is really 4x cubed. Derivative of negative 12, 0. So now that we have these two things, we're going to have to do some evaluating here. So the first thing we want to do is look at this x sub 0. So we're doing x sub 0 plus 1 is equal to x sub 0 minus f of x sub 0 over f prime of x sub 0. Well, we know x sub 0 is 3, so that's really just going to be x 0 plus 1 is equal to 3 minus f of 3 over f prime of 3. So I want to plug that into these two equations here. So I'm going to say f of 3 and f prime of 3. But I'm going to plug both of those into the calculator so I can use them throughout. And I'm going to say 3 stores x. And I'm going to grab that top function. I get 69. And then I'm going to grab the derivative. I get 108. So now I'm going to write this as 3 minus 69 over 108. And then put that in the calculator. So 3 minus 69 divided by 108. We could get a fraction. That'll be, well, let's just use 2.3. No, let's go 85 over 36 for now. This is equal to x sub 1. Now they want x sub 3, so we're going to have to go through and do this a few times. So we're going to say x sub 1 plus 1 is equal to, and then we're going to have x sub 1, which would be 85 over 36, minus f of 85 over 36 over f prime of 85 over 36. So over here I'm going to write f of 85 over 36 and also f prime of 85 over 36. So I'm going to use my calculator to do all this work. So I'm going to grab 85 over 36, store it as x, grab the original function, and then do the same thing with the derivative. And I get 19.07. And I get 52.65. So this is going to be 85 over 36 minus 19.07 over 52.65. And again, I'm going to use my calculator here. Minus, let's go parenthesis, divided by, I get 1.9987, that's x2. Okay, now we're going to go for x3. I'm probably going to do most of this in the calculator because the numbers are getting nasty. But x2 plus x1 will equal x2, which is 1.9987, minus f of 1.9987 over f prime of 1.9987. Now I'm going to do a lot of this work in the calculator. So we're going to store this number as x. And we're going to grab the original function. And we're going to grab the derivative. And we get 3.95. So we're going to say f of 1.99 and f prime, I shouldn't put it that close, f prime of 1.99. So I get I'm going to put 3.95 here. And this one would be 31.939. So I end up with 1.9987 minus 3.95 over 31.939. But I'm not going to use those numbers. I'm going to use what's in the calculator. So this number minus, I better go back and put parentheses. This number divided by 31 there, I get 1.87, round to the thousandth, 875. This is x3. So this is an approximation for the value of the fourth root of 12.